Hello.
Welcome.
Yes, this is Abdurrahman. I just want to make a note that this is for the ICT. It is not the.
Okay then. Sorry for the mistake.
No problem. No.
We're
So
shifting to the ICT pillar. Yeah.
My name is Abdurrahman Mahmoud, as Dr. Labaidli mentioned. I'm here to present human circulatory system simulation for extracorporeal membrane oxygenation and therapy. I'm presenting on behalf of myself and my team. My teammates include Ayman Abdul Karim, Amran Abdullah, El Sheikh Muhammad, and our LPI is Dr. Faisal Binti Ali, and our co-PI from HMC is Professor Guillaume Alinier. And for the background, I would like to discuss what is extracorporeal membrane oxygenation, and it's basically short-term artificial hearts and lungs that is used for supporting a patient that has lung or heart failure. And basically, what is done is, in order to turn on this machine, you have to reroute the blood from the body into the ECMO machine, and it's done in a similar fashion to dialysis, where a cannula goes into the body and extracts the blood and passes it over the machine in order to oxygenate it. Very recently, as we know, the crisis of COVID-19 has scourged like the earth. ECMO was found to be very useful in patients that have the problem of lung failure, as it gives them a chance to recover from the lung failure. Actually, even in Qatar, 2 out of 50 patients are being treated using the ECMO machine. And it's very important to mention that in order to do cannulation for the ECMO machine, which is the process of inserting the cannula into the body, there has to be a lot of training, as it's very intensive and it's very dangerous. Usually, in order to train the healthcare individuals, training is conducted using mannequins that are used in order to simulate or emulate a human body. So here, our aim is to introduce, our aim is to create the next generation cannulation simulator, which is a collaborative project between Qatar University and HMC in order to develop and emphasize on these 4 points: cost efficient, realistic, and educationally effective ECMO SBT system, but not just cannulation simulator, but the whole system. So first, our simulator composes of multiple parts. There's the patient part, which is the cannulation simulator, what we're working on and what is our scope of this exact project. There is also the ECMO machine, which is simulating the ECMO machine itself, and there's simulating the heater in order to convey all of this or create this full system. So if we go through the literature review, there are 3 very popular simulators. You have the earlier simulator, which is very expensive, costs around 33,000 euros. And then you have, and it has limited anatomical realism. I'll go through this later. And then the CK Allen, which has only veins simulation. So it simulates only the veins or the veins or one single loop of the blood. And lastly, T-Endo, which simulates in a makeshift way both loops, but it also requires an ECMO, a running real ECMO machine in order to operate it, which is very, very expensive. Here in our design, we have our idea of the next generation cannulation simulator, where you have first the closed loops, which composes of the tubes that the liquid runs in, and the special connectors that are used, and also the motors or the pumps that are used are controlled using the controller. We have also the cannulation access points, which are highlighted in dark red, and these are where the cannulas or the insertion of the cannula goes through. And it's very critical in order to simulate or emulate and teach healthcare participants how to do cannulation. And then the third part, the procedural emergencies, which is our novelty, which are composed of like simulating what could go wrong in a surgery and how to alert the instructor if the patient, if the trainee goes through such fault. So our design also has an embedded system aspect in order to actualize all of this. We have flow sensors in order to measure the flow of liquid in the tubes. We have the force sensing resistors in order to emulate the internal bleeding case. And then we have DC motors for pulsating effect at the access points. And then lastly, we have also the pumps that actually pumps the blood, the liquid that emulates blood into the system. For the closed loop, we consider, as of results, for the closed loops, we considered very realistic diameters for the tubes, for the arteries and the veins. And also we 3D printed the realistic connectors in order to make them as realistic or as human-like as possible. And thirdly, we also generated pulsatile flow for arteries and laminar flow for veins in order to emulate exactly how the whole pumping of blood happens in the body. The cannulation access points are, as I said, a focal point in our project, because cannulation is as important. Like cannulation is our topic, and the insertion of the cannula is the most sophisticated procedure of cannulation. So first, we made a mold in order to make the access point, and then we designed it based on ultrasound image of the femoral area in order to emulate where the cannulation happens, and the femoral usually and the jugular. And then after we made the mold, we basically poured in ultrasoundable material, which is EcoFlex, in order to emulate the human touch, and also in order to make the material see-through with ultrasound, which is the guiding method in cannulation usually. For the procedural emergencies, we have implemented two methods of procedural emergency. Internal bleeding, which happens when the cannula goes into the simulated renal vein, and typically when this happens, there will be internal bleeding and the patient might die. So we're trying to emulate it in order to make the lecturer aware of this in case it happens. And bleeding using the flow meters, basically we're continuously measuring the flow and detecting how much liquid is lost in the system. So the overall systems of the arterial and the venous loops were connected. The arterial had no leaks and ran very nicely. The venous loop had minor leaks that we're working on and will continue to work. For discussing the results, we carried out an important test with HMC's doctors, ECMO doctors and nurses, and perfusionists. We also would like to iterate that our model is better in terms of realism, as it focuses on the anatomical realism, and it shows exactly how a human body would look through an ultrasound. Also, we focused on price in order to make the whole system cheap and easy to use.
Abdurrahman, excuse me, Abdurrahman, you have 2 minutes.
Sure. Well noted, thank you. Also, immersion, we want to immerse the trainee into in the training and include the lecturer. Some limitations we bumped in is the 3D printed parts precision, because our 3D printers weren't very accurate. Also, we had a problem with the DC pumps precision. In order for the project, post-project plans, we were intending into improving the performance of the overall system. And also we intend to introduce new procedural emergencies like seizure mode and tachycardia. We're also working on integrating the next generation cannulation simulator with a full environment, which includes the ECMO machine as well and other things. And also we would like to conduct a conclusive effectiveness study at HMC in order to assess how effective this simulator is at teaching. To conclude, we have phase 1 was fully implemented. Procedural emergencies were tested at HMC and QU. And also we have very good incentives from extracorporeal life support organization ELSO when we met them in the symposium organized in Qatar. And we've submitted 3 abstract journals, 2 IEEE conference papers, and we won 2 best paper awards in the previous conferences. And we have one full journal in progress right now. I would like to thank Engineer Abdullah Salmi for his time and effort in assisting us. He worked on the previous part and the ECMO machine itself. We would like to also thank Dr. Ibrahim Fawzi, the head of the MICU. I would like to thank Dr. Ali Ed Hassan and Mrs. Abir Ahmed and Mr. Brian Collado and the rest of the HNC ECMO team for their clinical advice and guidance. And I would like to thank also our colleagues that helped us with the 3D printer. And I would like, of course, lastly, thank the UREP for this grant and this opportunity in order to share our work with the world and with you. Thanks a lot. I'll be very happy to answer all your questions now.
Thank you, Abdurrahman. Dr. Munir, can you go ahead, please?
Yeah, thank you very much for the interesting presentation, interesting work. Yeah, you mentioned that you have a prototype now and you are testing it, and also you are collaborating with HMC, which is good. But just I have a comment regarding your comment where you said that our model is better, and also the price is interesting.
It's here.
So, did you compare, for instance, your approach with another approach? In Poland, they have a prototype of extracorporeal membrane oxygenation chemotherapy simulator. There is a paper published in 2018 in PubMed. So, I mean, I don't know if you are aware of this work. I mean, how does your work compare to this work? And in terms of the challenges you are meeting, in terms of 3D printing, how you are trying to overcome that and have something that is pricely interesting from price perspective.
Thanks a lot for your question. It's a very important point. Yes, I am aware of this paper from Poland. We've checked it out and we've analyzed it. What they're doing is mostly simulating the whole system, but they don't have some sort of cannulation procedure or cannulation model. So what they're doing is that they have the ECMO machine running and then they have some sort of demonstration. But unlike us, we have an actual cannulation access point. So the trainees can cannulate the system. If you can see through the pictures, like if the ultrasound is already running and there is cannulation. So it's a bit different. We actually included them in our literature review and the report if you would like to see that. But yeah, as I said, our project is more intensive and it actually includes cannulation, unlike theirs. Also, another important point is that realism, as I said, no one has a similar aspect when it comes to simulating anatomical realism using ultrasound images, which is something special that we did. Also, no one has the aspect of procedural emergencies, which is our novelty idea.
Thank you.
Yes. Thanks for your question.
Thank you, Dr. Hisham. Thank you, Dr. Hisham, please.
I raised my hand and then lowered it because Dr. Munir asked the question. No, not about the paper. I wasn't aware of the paper, but actually a comparison and benchmarking.
No, we can receive 2 more questions. One.
But I would like just to make a comment. I very much like the biomimicking aspect of what you did, including the pulsating flow in the arteries and the laminar in the. I'm not sure if it's laminar or turbulent, but it's certainly steady. Not pulsating in the veins, but I like the biomimicking aspect of what you did. I think that was very realistic and to be commended. Thank you.
I would like to comment on that if it's possible, Mrs. Dr. Abaidli. Okay, thanks a lot for your comment.
Just go ahead, yes.
the pulsating effect is only on the arterial side. So this is the ingenuity of what we're doing. If you find in the final simulator, it's only on the arterial side in order to show this pulsating in the arteries, but not in the veins. And actually, when the cannulation is done, this is how the trainees or actually the healthcare professionals can recognize or identify the arteries from the veins. So this is a very genuine and interesting way to teach the trainees how to find the arteries, which could be very difficult sometimes. But thanks a lot for your comment and your insight.
The last question is from Dr. Hatem Hani.
Well done, Abdurrahman. Quite amazing findings.
Thank you.
I consulted the final report of this project, and I noticed that among all the students who took part in this research, Ayman Abdul Karim was the one who really performed very well. Do you agree with me?
Thank you. Yeah, we all work together, and it's not in question who worked better than others. What's question is, did we finalize the project and did we work all as a team? And this is the most important and essential part of our project.
So Ayman wasn't the best one.
We're all the same. We're all working together.
Thank you, Dr. Hatem. It's a teamwork, I think.
Yes, thank you. It's a teamwork effort, and I'd like to emphasize on how important it is to have different insights. Actually, our team was mechanical engineers and electrical engineers, and it was very important to coordinate together and work together in order to achieve this and show a really good product in the end.
It was important to hear you telling us this.
Thank you, Doctor.
Thank you, Abdurrahman. And I hope this is a learning experience for all of you joining us today. Now, I would like also to invite Nihar from Qatar University to present the research project titled Development of Independently Controlled Four-Wheel Drive System for Autonomous Electric Vehicle.
Hello, good afternoon, everybody. I'll just share my screen.